Alright, so in this video I wanted to talk about Arduino integration on a robot. Now, just for sake of context, I have an Arduino Uno revision 3 plugged into one of the USB-A ports, one of the two ports that we normally plug a camera into my RoboRIO, and I am hooked up to my RoboRIO as well. What I wanted to demonstrate was how you could send a signal over USB to the Arduino from the RoboRIO and get something back. This will be particularly useful if you're working with a PixieCam or you have sensors attached to an Arduino that you're trying to read from in order to get feedback information. Normally, what you don't want to do is have the Arduino just spamming the RoboRIO with information, because you really don't have a good way of pulling out the most recent information. You should only ever send a signal to get back what you ask for. You shouldn't really allow the Arduino to just sort of bum rush the RoboRIO with information. So that's what this video is going to be all about. I have in front of me right now on screen the Arduino Ide, Arduino code being written in C and C++ for those of you who didn't know. And we've got two methods. One is called void setup, one is called void loop. Void setup runs once when the Arduino program first starts up. It's for general setup and what have you. Void loop gets called as fast as physically possible on the Arduino over and over and over again in order to actually have some sort of repeated program that actually accomplishes something. So in void setup, we only have one piece, serial.begin 9600. Serial is the communication type that we're using in order to communicate back with the RoboRIO. Serial.begin just sets up all of the hardware required to communicate with the RoboRIO on the Arduino. The 9600 is important. We'll need it for when we set up the RoboRIO, but the 9600 is something called a baud rate. It's basically a speed in which you can transmit data over a serial connection. The numbers have to match for both the RoboRIO and the Arduino if you want this to work correctly. 9600 is a good value to start with, although there are other numbers that you can use in order to increase the amount of data that you can send and receive in any one given period of time. There's a good Wikipedia article on baud rates that goes into things in more detail. So in our void loop, we have an if statement. And it says serial.available. Basically what this says is, are there any bytes available to the Arduino in its buffers with data in them? If there are, what we do is we store a single byte using serial.read into a variable called value. And then I specified just a value of hexadecimal 12, decimal 18 to be my number of choice. I just chose it at random. And I said, if the value equals 0x12, then we're going to print a string that says, hello, I received code 0x12 to the to serial, to the USB connection. And then, of course, down here I also have a delay. Delay is in milliseconds on the Arduino, so this will delay the loop by 50 milliseconds each time it runs around, just to make sure that we're not doing too much stuff too quickly. This is more of a force of habit thing for me. In earlier versions of the Arduino software, having the loop running free speed as fast as it possibly could cause problems with how the application ran. It's not so much of an issue anymore, but 50 milliseconds is pretty good, and you can also set it lower if you want it to be 1 or 20 to match the RoboRIO, that sort of thing. It's up to you. But I just chose 50 because it was a nice, easy number. Now we're going to look at the code that makes the RoboRIO work. So we're going to jump over to my example right here. Now, I actually do have this code running, I believe, but it doesn't look like I'm connected to the RoboRIO at the moment. So let me see if I can get myself connected using the driver station just so you guys can see what it sort of looks like. Maybe? No? It's still making an effort. There we go. It's coming. Oh boy. Hey, there we go. It's sort of... Ooh. There we go. Okay. My computer's running a little bit rough because I'm also recording, but as you can see over here in the monitor, every once in a while there's a new set of strings that show up. But we'll talk about that in a minute. So, up here, I've got two things. Serial port Arduino and private timer. So the serial port object is what we use to communicate over the USB connection to the Arduino. The timer is just used to determine how often I want to send that hexadecimal 12 to the Arduino from the RoboRIO to get something back. Fairly straightforward, not too terribly complicated. Where things start to get a little bit weird is with Robot Init. So if you look at this gigantic try-catch block, for those of you who aren't already aware, try and catch in Java is a mechanism by which you can try to accomplish something, and if it fails, grab that failure and do something else as a result of it. So one thing that I noticed while I was experimenting is if by some chance the RoboRIO does not have an expected serial device hooked up to it, that you try to create a serial port for, your code will fail to run because it will throw an exception saying that it couldn't connect to the serial device that you had specified. So this try-catch statement is designed to sort of circumvent that issue, and here's how. There are technically 3 USB ports that are currently enumerated on the RoboRIO. That's the USB-B port that we normally use for imaging the RoboRIO and similar work. And then there's the 2 regular USB ports, which you're all accustomed to seeing on regular computers, that we would normally use for like a camera. What I've done here is I've set it up so that the RoboRIO, when the robot first starts up, will try every single one of those named ports to see if it can connect. And if it can't, it will just tell you that all the connection attempts failed. So, for example, Arduino equals new serial port. Here's that same baud rate again, and then serialport.port.kusb. What I've noticed is that more often than not, the first USB device plugged into the RIO is going to be what KUSB is. And subsequently, KUSB1 would be the second, and KUSB2 would be the third. Not necessarily always the case, which is why this try-catch exists, especially if you're changing up camera configurations and what have you at the same on the same connections. But basically, it will try it with this first. If for some reason this fails, it will skip and then move into the next try-catch that tries it with KUSB1. It will skip that, and it will try it with KUSB2 if that one fails. Now, do we really need to do all this? Debatable. We would want to play a little bit more with it just to see what it would be like to have a camera also plugged in, because right now I don't have a camera plugged into my robot. But in this instance, what we have is just some mechanism by which we can we can make sure that we always connect to a serial port. Now, the only other thing that I do is I create the timer and I start it. Because the way I'm going to set this up is, as long as the robot is running, we're going to keep requesting data from the Arduino. There's not going to be any waiting on the robot to be enabled or in a particular mode in order to be able to accomplish this. It's always going to be running in the background, so to speak. The way I accomplish that is by using robot periodic. It's another method that we don't always see when we're setting up our robot code that runs roughly every 20 milliseconds whenever the robot is on. So what I do is I say if timer.get is greater than 5, so if the timer has counted up to something greater than 5 seconds, we're going to print wrote to the Arduino, and then using the serial port, we're going to write a new byte array that only has 1 byte in it, and that is that 0x12 code that we were talking about with the previous piece of code. And then this last piece here is just the number of bytes that we want to send. In this case, obviously, it's only 1. The next thing that we're going to do is we're also going to reset the timer just so that it starts counting back from 0 again to count up to the next time that we should send the code again. The other if statement that we have is if Arduino.getBytesReceived is greater than 0. This just checks to see if there is anything in the sort of queue to pull from the serial that is connected to the Arduino. If there is stuff to grab, we say system.out.print Arduino.readString. ReadString, what it does is it takes every single byte that is in the buffer, the same buffer that is used by getBytesReceived, and puts it into a string. Now, the reason why we call print is because if you look back at our code for the Arduino, I called print line. So you can imagine this as having sort of like a special hidden character that's added to the end of the string that we specify that indicates that there needs to be a new line at the end of the line. So that new line character will also come through in the buffer. So we just keep calling print until the whole buffer has been read through, and that should include the new line, which is why if you look over here at the output, it starts writing the wrote to Arduino on a new line because there is a sort of hidden character here that indicates that there needs to be a new line there that's also coming through in the text that I'm sending from the Arduino. And that's basically it. Obviously, it will be a little bit more complicated if you're trying to integrate sensors or a Pixie Cam. Obviously, your Arduino code is going to be more complicated than just a few lines. Your code on the RoboRIO itself will probably be more complicated to interpret the data that's coming from the Arduino, but this is the general gist of how to actually connect an Arduino to a RoboRIO through a USB port. That being said, there's a couple of things that I want to mention. It's really not a good idea to try to send strings of data, i.e. like strings of text, back from the RoboRIO. I mean, back from the Arduino. The reason this is because let's say that you have a number that can be between the values of 0 and 1024. And you're trying to send that number back to the Arduino. Well, if you're sending that back to the RoboRIO, I keep getting my names confused. You're trying to send a value of 0 to 1024 back from the Arduino to the RoboRIO. If you're sending the number 0, you're sending 1 character. If you're sending the number 1024, you're sending 4. So it would be kind of difficult to know what's in the buffer for a string that you had to read out. So if we were to actually look at serial port, there is another type of read string method that takes a number of characters that you want to read out. So what you'd end up having to do is either pad the string, so like if you had 0, it would be 0000, or if you had 1024, it would just be 1024. If you had, I don't know, 48, you would have 0048. It adds a lot of extra work. So if you're sending data back and forth, what you're really going to want to do is send it back and forth as byte values, similar to what I've done here, and have the first byte that you send, or the first 2 bytes that you send, be the number of bytes of data that are coming through from the device. So like, let's say that you had to send a regular integer from the Arduino. A regular integer, at least for the context of this video, is 4 bytes. So if you were sending over that integer, what you would do is the first byte that you send from the Arduino would be 4, a value of 4, and then that would tell the RoboRIO, okay, there's 4 bytes of data that I should expect to see that I want to read out. So then you would go through and you would read 4 bytes of data using the serial port object from the RoboRIO. Now, I know this is a lot of me talking. It would probably be better if I did an actual example at some point. This was just to get you guys looking at it and understanding it somewhat. That being said, we can probably talk more at a build session. If I need to make another video, I will. But this was just to sort of give you guys a general idea of what the code needed to look like in order to do what you had originally wanted to do with the Pixie connected to the Arduino. So this would be your starting point in order to be able to get communicating and experimenting from there. That being said, obviously, as with any of my videos, any questions, email, Facebook, text me if you have my cell phone number somehow, or if you really wanted, you can leave a comment below the video. I'm probably not going to post this code because it would be relatively quick to copy from the video itself, and I'm in the process of transitioning my GitLab server from one computer to another, so I'm not going to try to fight with that right now. That being said, ask questions, and hopefully we'll be able to get this sorted out nice and quick so that we can do some testing of tracking objects on the field.